Hello students, good evening. Good evening, JNV Davangere students. Good evening. How are you all? YouTube Live students, good evening. So, how was the numerical session yesterday? Were you able to solve problems and all? Yes. Yeah, so in the meantime, as students will be joining, please let me know is my screen visible or not, and the audio quality also. Later on, I'll take the technical check, but please let me know, students, Davangere students, okay? And yeah, apologies for my voice, okay? So due to health issues and all, my voice is not that clear. So give me a day or two, so everything will be fine. Good evening, Tirth. Yeah, how are your teeth, Tirth? Yeah, Tirth, let me know, is my audio, is my presentation visible or not? And also during the classes, if you face any issues regarding, let's say, problems or the concept, or let's say technical issues, please let me know using the chat, okay? Okay, good. Thank you, Tirth. Good evening, Parth. So we'll be starting the session, let's say 6:45. 1 minute more. Good evening, Parth. I'm good, Parth. I'm better than yesterday. Yeah, yes. I'm better than yesterday. Okay, Parth. Yeah. So please let others know that we'll be starting the session if you have any contacts. Okay. So please let the students know that we are going to start the session. Parth, Tirth, okay. Okay. Good evening, sweetie. Welcome to today's session. So, students, myself, Samanvit, your physics faculty from Avantifellows. Good evening, good evening. So, students, we were talking about what? Newton's laws of motion. Yes, in that we have talked about all the three laws. And in yesterday's class, Abhishek sir might have told you about regarding certain numericals, right? There you need to find the velocity and other things and all. Yes. Today we'll be like looking more into those concepts itself. Today will be there'll be let's say concept which will help you to solve like JEE need questions. Okay, it will be focused on that itself. Okay, students. So before moving ahead, let us quickly go to the content of today's session. What we are going to study today. One thing is quick recall. Okay, what we have studied in the previous, let's say on let's say what's the date today is 3, right? So what we have studied in the, let's say, Feb 1st, what you have talked about. Okay, then there'll be a recall question, guys. So I'll be giving you only 3 minutes of time to solve it. Right now you should be able to solve any questions that is what thrown at you. Okay, because it's very important, because our level of problems that are going to come from here onwards will be much more complicated, but it is easier unless and until you don't practice it. Okay, if you don't practice it, it will be much difficult. Then we'll be solving a numerical. Okay, before solving a numerical, tell a concept. That concept will basically help you to solve the problem. Okay, it will help you to solve the problem. Then later on we'll be talking about what constraint relation. What is this constraint relation? You know what it is. Basically, you know the meaning of it. It is basically, I mean, it basically tells what the meaning tells itself. So it's very easy concept. Don't worry about that. Then later on, we'll be talking about what? Movable pulley. Okay. In constraint relation, we'll be talking about movable pulley. First, we'll be talking about what? Like the pulley that is. Abhay, good evening. Good evening. Welcome to today's session. Later on, we'll be talking about, okay, initially the pulley will be what? Stable. Okay. Or let's say it's fixed pulley. Then we'll be talking about movable pulley, which is much more important for your NEET and JEE. Okay. Then what? Later on, we'll be talking about the summary, students. So do you remember what we have studied in the last class? Let's say February 1st. Do you remember, students? Have we gone through all the concepts we have studied? Yes or no? Let me know in the chat. JNV Davangere students. Yeah. Yes. So what we are talking about? Yes, very good, sweetie. We were talking about what? A spring, right? A spring, basically. A spring is a metallic wire where we saw. And what did we say? Let's say if this is a spring, or let's say if you're in whatever notation you want to. Achha, Abhay, don't worry, it's okay. Basically, I will be telling concepts which are much more important and which will help you basically understand yesterday's class. Okay, don't worry about it. Yesterday's जो भी problems हुआ है वो आज से समझ में आएगा, ठीक है ना? क्योंकि कल मेरा health issues था तो इसलिए ऐसा हो ना, मतलब it happened in such a way that there were certain problems that need to be required to be solved, but it's okay, don't worry, we'll be solving. So today there will be concepts that are much needed to understand yesterday's class. Much better. Okay, thank you. Then what? So when two free ends of the spring, let's say this is my spring. Yes, this is my spring. When the two free ends of the spring is pulled away or what? Pushed towards. If I'm pulling it away or pushing towards it, the length of the spring changed. Yes or no? If this is the length of the spring L0, as I said, if I'm pulling, then the length increases. Yes or no? Let's say L0 plus X. And if I'm pushing, the length decreases. Yes or no? That is L0 minus X. Yes. Then later on, I also said that the spring has a tendency to come back to its original length or develop the opposition to its changes length. And this opposing force is the restoring force. Yes. Let's say you have this spring of length L0. Okay. L0. Now, if I'm trying to stretch, if I pulled it away, then you know that the length changed L0 plus X. But if there was this force F that was applied. There is a force that was applied. Now, if I remove this force, then there will be basically when I'm pulling it, there is a restoring force, and I call it FSP. Yes or no? FSP. Yes or no, student? That is spring force. This is the spring force. This basically tells us that the spring will come back to its original position when you remove that force. Yes or no? Then I told you that there was this famous scientist Hooke, right? Hooke, or he gave his law, Hooke's law, which said basically told us that FSP is what? Let me know. What is the relation he gave? Students, let me know. Suman, welcome to today's class. Yes, what was the relation he gave? Minus K into X. Yes or no? This was the relation he gave, where he told that this restoring force is basically proportional to the displacement. From that we got this when removing the proportionality constant. Yes, sweetie Parth, do you remember all these things? Yes, students, let me know. Students in the YouTube live, let me know. Yes, Aishi, very good. Okay, good. Yes, very nice. So then I told you that what is this K? K is called what? Let me know, students. What is K? Yes, Parth. Very good. And I gave a homework too, right? What constant? Yes, I know it's a constant. What is that constant called? What is this constant basically? Yes, this is the spring constant. Very good. Very nice. Spring constant. And X is the Displacement. Yes or no? Very nice. Yes, students. And also I told you that let's say if there was a, let's say, spring, and if I'm pulling with x1 meter on the right hand side and x2 meter and at the left hand side, so what will this spring force be, FSP? Let me know. What was it? Okay, very good path. That is what? Minus k into delta x, where delta x is what? X1 plus x2. Yes or no? And this was the relation. So this is an important relation. Okay, this is a very important relation. So please keep it in mind. Okay. And also, I guess I gave a problem based on it. There was a problem based on it. Okay. And also, I gave a homework problem. Did everyone do it? Homework problem. Did you solve it? Let me know. Did you solve it or not? Okay, good. Very good. Very good. Others, let me know. Aishi, did you solve it? Path, Teeth, Davangere students, Bagalkot students, did you solve it? Okay, sweetie. Very good. Very nice. See, others, you need to solve the questions that is given. Okay. Path, very good. Awesome. That's very good of you. Okay, JNV Davangere and JNV Bagalkot students, please let me know. Okay. So if you haven't solved it, you need to go back and solve it. Okay. All the videos are available in YouTube also, and also I have shared the drive link. I guess in the last week, so you can the notes is available over there also. Otherwise, I'll be sharing at the end of the class. Okay, don't leave the class. Before ending the class, please remind me to share to make sure that I share you the drive link again. Okay, is it good? Okay, good. Thank you. Now, if that is the case, students, then here is a recall question for you guys. Okay, so I'm giving you exactly 3 minutes of time to solve this. Okay. Yes, Abhay. Okay. So here, what it is given that if the system is in equilibrium, so basically the system is in equilibrium, then find the tension, acceleration, and extension in the spring. Given that K is what? 100 Newton meter. Okay, Newton per meter. Is it good? So what is happening here? There is 1 kg mass and there is a hinge over here. This is hinge basically. Hinge. It is connected to a string. Okay, and there is this 2 kg mass which is also connected to a string. This 2 kg mass is connected to a spring to a 3 kg mass. Now, students, you need to tell me what is the tension, what is the acceleration of the system, and what is the extension in the spring. See, you know that the acceleration will be along this side, obviously, right? Yes or no? So please let me know what are the values. I'm giving you exactly 3 minutes. Okay, please solve it, students. Please solve it. Here's a 3 minute of time. Please solve it, students. If you're able to solve this is much more easier. Okay, then every problem that we'll be solving, it will be very easy for you. Come on, start solving. See, hint is, I'll give a hint for everyone. Okay, solution hint is draw the FBD of everything. Draw the FBD first. If you draw the FBD, then you will be able to solve everything. Okay, solve FBD for 3 kg first. Then you'll know what are the forces that are acting. Then draw the FBD for 2 kg. Then you'll know what are the forces acting. Then draw the FBD for 1 kg. Then you'll get to know. Okay, try to solve it, students. And let me know if you're solving or not. Ayushi, you need to solve it. Let me know. Harish, if you're available, please let me know what is the answer for it. Where do you, okay. Where do you see the tension, Abhay? Where are the tension acting? See, this is the same string, right? So tension over here is upside, tension over here is downside. So tension is same. So wherever you find the tension, it will be same, right? That's all. So it doesn't matter from where you find. It just matters ki you need to find the tension. JNV, Davangere and Bagalkot students, are you able to solve it? Suman, let me know. Path, Sweetie, Tirth, let me know, students. Okay, Path, very good. Sweetie, very good. You need much more time? Let me know. Should I give you 1 more minute? By no, try to solve it again. It's okay, bhai. Are you sure? Check once, Abhay. Okay, I'm giving you extra 1 minute. I'm giving you extra 1 minute to solve it. Okay, try to solve it again. Krishna, welcome to today's session. Okay, last 10 seconds. Okay, then I'll try to solve it. Okay, then we'll be solving together. Okay, time's up. Chalo, let's solve it. Students, should I solve it? Let me know. Batao. Okay, no problem. Let's try to solve it. Okay, let's try to solve it. No problem at all. See, first thing is let's do the FBD of every let's say mass. Over here, let's take the first one as what? The 3 kg mass. 3 kg mass के लिए पता है कि weight act करेगा नीचे. तो weight कितना होगा ये बताओ. अब मैं डायरेक्टली लिखूंगा. वो क्या है? आपने G को 10 मीटर पर सेकंड स्क्वायर ही लिया होगा. ठीक है. तो कितना 30. हाँ, वेरी गुड. अब see, the thing is over here it is said that the system is in equilibrium. इक्विलिब्रियम का मतलब क्या है कि ये नीचे आ चुका है ना स्प्रिंग की वजह से. अगर ये नीचे है, वेट नीचे एक्ट कर रहा है, तो एक फ्रिंग फोर्स एक्ट करेगा ना ऊपर. yes or no in the opposite direction. yes or no students. Similarly there be a spring force FSP over here also. Now on the 3 kg weight, then there will be a spring force that is acting. yes or no FSP. ये हो गया FBD इसका. Is it good? Let me know students. yes or no? Let me know students. जल्दी बताओ. yes, good. अब देखो सेकंड इसके लिए 2 kg के लिए आपको पता है कि ये यहाँ है, तो यहाँ नीचे एक वेट एक्ट करेगा. yes or no? उसके साथ एक स्प्रिंग फोर्स भी है FSP. तो यहाँ एक वेट टैग करेगा, वो क्या है 20 है ना, न्यूटन. And also there will be another force that is acting FSP. yes or no students? Similarly there is a tension that is acting upwards. yes, is it clear? ये सही है, यहाँ तक सही है. very good. yes. Now for the what 1 kg mass, देखो 1 kg mass इस डायरेक्शन पे है ना, यहाँ है, इसलिए मैं ये चेक कर रहा हूँ. देखो सिर्फ एक फोर्स से एक्ट करेगा ना जो हमें चाहिए. देखो एक्सीलरेशन हो रहा है इस तरफ, एक्सेलरेशन इस तरफ है, तो हमें जो फोर्सेस चाहिए वो सिर्फ एक्स डायरेक्शन में चाहिए ना, है कि नहीं. तो एक्स डायरेक्शन में सिर्फ टेंशन है. yes or no? नाउ इफ दैट इज अ केस, इसके लिए जो हम लिखेंगे वो कैसा होगा. आपको पता है कि एक्सेलरेशन इस साइड है, इसको भी एक्सेलरेशन इस साइड है, इसको एक्सेलरेशन इस साइड है. तो फॉर दिस how can I write the equations? Can I know students? Let me know quickly. Can I write 30 minus FSP is equal to 3 into A। ये पहला वाला इक्वेशन हो गया। यस, इसके लिए कैसे लिख सकता हूं मैं? इसके लिए ऐसे लिख सकता हूं मैं, लेट मी नो, 20 प्लस FSP माइनस T इक्वल टू, वेरी गुड पाथ, 2 है। ये हो गया सेकेंड इक्वेशन। इसके लिए कैसे लिख सकता हूं मैं? आपको पता है कि एक्सेलरेशन इस साइड है, तो कैसे लिख सकता हूं मैं? T इज इक्वल टू, जो भी फोर्स आ रहा है वो 1 into A। ये वो आ गया थर्ड इक्वेशन। यस और नो? सो व्हाट आर द इक्वेशंस वी गॉट? वी गॉट 30 minus FSP is equal to 3 into A, ये वाला पहला था, और एक और था क्या, 20 plus FSP minus T is equal to 2A, ये सेकंड था, और थर्ड वन था T is equal to 1 into A, ये थर्ड था। अब मैं क्या करूंगा, सब्स्टिट्यूट 3 into, ठीक है, 3 into 2, तो क्या क्या होगा, 20 plus FSP minus 1A is equal to 2A, है कि नहीं? Then rearranging, I'll get 20 plus FSP is equal to 3A। ये थर्ड इक्वेशन हो गया, थर्ड नहीं, फोर्थ इक्वेशन हो गया, ठीक है। अब मैं क्या करूंगा, फर्स्ट और फोर्थ को ऐड करूंगा, एडिंग 1 plus 2, तो क्या हो जाएगा, लेट मी नो स्टूडेंट्स। 1 plus 2 ऐड करूंगा तो क्या होगा, 30 minus FSP is equal to 3 into 3A, ओके, और 20 plus FSP is equal to 3A। ऐड करूंगा तो ये दोनों कैंसिल हो जाएगा। 20 plus 30 is 50, 50 is equal to 6A, A आ जाएगा क्या, 50/6, है कि नहीं? दैट इज मीटर पर सेकेंड स्क्वायर। ये आ गया एक्सेलरेशन, हमारा आंसर आ गया। हमें चाहिए टेंशन, आपको पता है T is equal to 1 into A, so T is equal to 1 into A is 50/6, so टेंशन भी आ गया 50/6 न्यूटन, है कि नहीं? वेरी गुड, यस। अब देखो, हमें एक और चाहिए था, क्या चाहिए अभी, हमें चाहिए एक्सटेंशन इन स्प्रिंग, है कि नहीं? एक्सटेंशन इन स्प्रिंग के लिए हमें चाहिए FSP is equal to minus K into delta X। K हमें दिया है 100 न्यूटन पर मीटर, ये हमें डायरेक्टली दिया है। यस, वेरी गुड। हमें चाहिए FSP। देखो, FSP के लिए हम यूज करेंगे ये वाला इक्वेशन, ठीक है। हमें पता है 30 minus FSP is equal to क्या, is equal to 3 into A। हमें आया A is equal to क्या आया, 50/6, तो यहाँ सब्स्टिट्यूट करो, तो I'll get FSP is equal to 30 minus क्या आ जाएगा, 3 into A आ जाएगा ना? यस, यस और नो स्टूडेंट्स? लेट मी नो। 5 is equal, अच्छा 5 आ जाएगा क्या, पक्का? 3 into what, 3 into 50/6, 3 1s are 3 2s are 2 1s are 2, 25s are 25 minus 30 is 5, FSP is equal to 5 न्यूटन। हमें चाहिए क्या, क्या, डेल्टा एक्स, so therefore delta x is equal to FSP divided by minus K, so delta x is equal to minus of FSP 5 है, divided by K is 100, so which is equal to 0.05 what meters। so this is our answer students। एक आंसर ये था, this is our answer। एक और आंसर ये था, this is our answer, and एक और आंसर ये था। इजी था ना ये? were you able to solve it students? let me know let me know in the chat, जल्दी बताओ। were you able to understand it? Please grasp everything what you have done now, check this once, okay, check this students। Kriday, very good, okay, very good। let me know Aishi, Kriday, were you able to solve this? others let me know। देखो, हमने क्या किया, पहले FBD किया, ठीक है, उसके बाद इक्वेशंस डाला, इक्वेशंस को सॉल्व किया हमने, उसके बाद हमें एक्सेलरेशन मिला, टेंशन मिला। अगर एक्सेलरेशन टेंशन मिला, हमने फाइंड आउट किया FSP, एफएसपी के बाद, दैट इज स्प्रिंग फोर्स के बाद. Okay, Path, it's okay. It's good, no? It's easy now. Okay, Abhay, very good, Path. Path and Abhay, very good. And also, we wanted the extension, which was basically find out by these equations. Okay, very good, students. Very nice. Very nice. Now talking about, there were certain concept based on pulley based numerical. Okay, there is certain concept that we need to understand first. Okay, see Abhay, that is the thing. See, the first thing you need to do is write the FBD. Okay, FBD बना के आपको आप ये देखो कि after FBD check where the acceleration is acting, check acceleration. और आपको पता है कि जो F इज इक्वल टू M इंटू ए, ये आपको पता है, लेकिन F होता है ना वो नेट फोर्स होता है कि नहीं? तो आप ये चेक करो कि नेट फोर्स कहाँ एक्ट कर रहा है कि नहीं? देखो, अगर एक्सेलरेशन ऐसा था, आपको पता है एक्सेलरेशन इधर है, आपको पता है कि वेट एक्ट कर रहा है, वो तो 50 न्यूटन, और एक एक्ट कर रहा है एफएसपी. देखो नेट फोर्स क्या होगा फिर, एक्सेलरेशन नीचे एक्ट कर रहा है ना, तो ये पॉजिटिव होगा और ये नेगेटिव होगा. तो 50 माइनस एफएसपी इज इक्वल टू एक्सेलरेशन. बेसिकली 50 क्या होगा, 50 माइनस एफ नेट है, वो ये एफ नेट है. ठीक है, ये एफ नेट है. और आपको चाहिए एम इंटू ए, और एम क्या है, उसका वेट है, जो भी वेट होता है ना, लेट्स से 2 kg, तो 2 kg उसका वेट है बेसिकली, है कि नहीं? सो 2 इंटू एक्सेलरेशन, बस इतना ही लिखना है. ओके ओके भाई, गुड, नो प्रॉब्लम. नाउ दैट्स वेरी गुड. हाँ, तो वही करो कि check the direction of acceleration. Check direction of acceleration. See, Abhay, we have gone through this in the let's say in the last week. So please go through the video again. Okay, you'll find the video in the YouTube, so you can go through that. Okay. Now, see, talking about the concept. Okay, here let's say you have, let's say mass A and mass B. Okay, in a pulley. So this is the pulley, and you have a mass A and mass B. Now the question would be, you need to find the tension and acceleration. ठीक है, एक टेंशन है, एक एक्सेलरेशन फाइंड आउट करना है. लेकिन आपका मेथड ऐसा होगा कि देखो, you know that for this mass there is a weight acting, that is what, ma into g, and for sorry, for this weight there is a for this mass there is a weight acting, that is mb into g, and you know that there is a tension acting in this direction, that is t, and there is a tension acting over here, t. Very good. There is a tension acting over t, and there is a tension acting over here, that is t. Now what you will be doing is you will be solving FBD. देखो, जब FBD सॉल्व करोगे तो कैसा होगा ना कि मास A के लिए कैसा होगा, लेट मी नो. मास A के लिए ऐसा होगा कि MA into G, और यहाँ टेंशन. ठीक है, और मास B के लिए कैसा होगा, MB into G, दिस इज मास B, एंड एक टेंशन एक्ट करेगा. एंड आपको पता है इफ मास B is greater than मास A, ठीक है, तो कैसे होगा कि एक्सेलरेशन इस साइड होगा ना, पार्थ वेट नहीं, पार्थ यहाँ देखो, दिस इज स्प्रिंग, दिस यहाँ स्प्रिंग नहीं है, ये स्ट्रिंग है, FSP comes in spring only. Students, don't confuse between a spring and a string. ये गलती मत करो आप. अगर ऐसे गलती करोगे कैसे होगा, ऐसे गलती मत करो आप, ये याद रखो ना. देखो अभी मैं सिर्फ बात कर रहा हूँ स्प्रिंग का ना, स्ट्रिंग, दिस इज स्ट्रिंग राइट, ये वाला स्ट्रिंग है ना. नहीं पार्थ, देखो दैट्स व्हाट, ओके, यू आर गेटिंग कंफ्यूज्ड विद सो मेनी फोर्सेस. स्टूडेंट्स देखो, पहली बात तो पहले ये याद रखो, ठीक है. पहली बात तो अगर स्ट्रिंग है, ठीक है, स्ट्रिंग है, तो फोर्सेस एक एक्सेलरेशन आएगा, एक टेंशन आएगा, बाकी कुछ नहीं आएगा। देखो, और एक और है, स्प्रिंग आएगा तो आपका एक्सेलरेशन आएगा, टेंशन आएगा और एफएसपी आएगा, ठीक है, बाकी कुछ नहीं आएगा। और अगर एक मास एक सरफेस पे रखा है, देन ओनली देयर विल बी अ नॉर्मल फोर्स, वरना नॉर्मल फोर्स नहीं आएगा। नॉर्मल फोर्स एक कांटेक्ट फोर्स है। Students, you need to go back to all the sessions that we have talked about. Okay, please go through it again. ऐसे कंफ्यूज मत करो अपने आप को, ठीक है? Okay. Now, if I'm trying to solve this question, students, you know that, see, over here acceleration is along this side and this is acceleration along this side. देखो, आपको भी पता है acceleration इधर है और acceleration इधर है। तो यहाँ इसके लिए solve करूंगा तो I'll get what? T minus m a g is equal to f m into m a into a, ऐसा or no? ये पहला वाला इक्वेशन है। और इसके लिए क्या आएगा? m b g माइनस t इज इक्वल टू m b a, है कि नहीं? अगर मैं इस दोनों को ऐड करूंगा, 1 + 2 करूंगा तो प्लस एडिशन करूंगा तो ये वाला कैंसिल हो जाएगा। फिर व्हाट इट विल बी? m b g माइनस m a into g is equal to what? m a plus m b into a, है कि नहीं? Yes. Now I told you that in the previous class, just a second, in the previous class कि अगर आपको acceleration find out करना है ना, अगर मान लो masses are connected, if there are masses are connected, I told you that what? In order to find the acceleration, you need to find F net divided by the total mass, है कि नहीं? Which is equal to basically acceleration is equal to F net divided by what? ma plus mb plus mc. ये मैंने बताया था आपको, है कि नहीं? Students in the YouTube, let me know quickly. ये सब याद है आपको? पार्थ, yes. अबे पार्थ, तीर्थ, let me know. दावणगेरे, तुमको, बागलकोट स्टूडेंट्स, let me know. हाँ, yes. देखो, यहाँ आपको ये फाइंड आउट करना है कि एफ नेट क्या है कि नहीं? एंड नाउ यू नो दैट इन दिस देर इज, देखो यहाँ देखो, जो ये फोर्सेस आ रहा है ना, ये बेसिकली क्या है? यहाँ अगर मैं इसको सॉल्व करूं फिर से, तो ये क्या हो जाएगा? एम बी इंटू क्या आ रहा है इधर? जी माइनस एम ए इंटू जी इज इक्वल टू वॉट? ए इंटू एम ए प्लस एम बी, and this acceleration is equal to what? mbg minus mag divided by ma plus what? mb. अब ये बताओ, let me know students, ಎಲ್ಲರೂ ಹೇಳಿ, JNV ಅವರು ಸಹ ಹೇಳಿ, won't this be F net, the forces that are acting, the total forces that are acting, and this is the total mass ಆಗುದಿಲ್ವಾ students? Won't this be something similar to that? Yes or no? Now you know that illi this is pulley और इधर ये यहाँ एक पुली के पास एक मास m है, a है, और there is mb. Now students, if you see problem something similar to this, can I picture this as something as माला? एक ये होता है ना, फूल का माला होता है ना, उसके तरफ can I imagine फूल का माला? ऐसा इमेजिन कर सकता हूं? अगर ऐसे इमेजिन किया तो इसको उठा के मैं एक सरफेस पे रखूंगा तो ऐसा हो जाएगा ना, ऐसा कनेक्टेड हो जाएगा ना, mb and m into a, and you know that for this there is a force acting. What is this? ma into g, and there is a force acting mb into g, है कि नहीं? और एक टेंशन इधर है और एक टेंशन इधर है। अगर मैं इसको पूरा एक सिस्टम मान लूं, then can I write something like this? then ऐसे लिख सकता हूं मैं। उसके बाद लेट मी नो स्टूडेंट्स कि ये जो आ रहा है वो नेट फोर्स है ना, आपको पता है कि एफ नेट फाइंड आउट करना है। व्हाट इज एफ नेट? देखो, एक अगर एक्सेलरेशन दिस साइड है तो एफ नेट क्या होगा? व्हाट इज एफ नेट? एम बी जी माइनस एम AG. Yes or no, students? And you know that if system is connected, then what you get? The acceleration is basically F net divided by the total mass. What is it? Total mass. Yes or no? So that is how you solve it. Did you get it? So अगर ऐसा कुछ आपने देखा, अगर ऐसा सिस्टम आपने देखा, तो डायरेक्टली अप्लाई करो ये वाला जो फॉर्मूला है ना, इसको डायरेक्टली अप्लाई करो, बस काम खत्म. लेट मी नो स्टूडेंट्स. तुमकूर, दावणगेरे, बागलकोट स्टूडेंट्स, स्वीटी. yes Parth. Yes Abhay. Parth, let me know. Okay. Ayushi, let me know. Okay, Davangere students, very good. So if that is the case, students, if you are able to understand it, Parth, let me know. Did you understand it? Okay, good. Very good. Tirth, let me know. Okay. So if that is the case, students, then solve this. Students. You need to find the acceleration and tension for this. This is very easy. Now we have solved how to find the acceleration. It is based on that previous concept itself. Try to solve this jaldi. So I'm giving you 2 minutes of time. Solve karo jaldi. Let me know in the chat what is the answer for it. This is much easier. Very good, Path. What acceleration is 2. What is tension? Okay, good. Abhay, check your answer. Sweetie, very good. Okay, Abhay. Sweetie, very good. Janvi Davangere students, very good. It's very impressive that you are able to understand the concept and you are solving the problems. Okay. I want the tension, Abhay. I want the tension. Aishi, solve the problem. Tumkur students, very good. Okay. You have solved it perfectly. Okay, last 2 seconds. I'm ending the this thing. Okay, nice. Now see, over here, as I said, what over here it is given that there is this 2 masses that is what attached to a pulley. Now you know that Path. No, check your answer once. Over here, you know that the tension is over here. Tension is acting along this side. There is a tension that is acting over here. There's a tension that is acting over here. Yes or no, students? Now, you know that there is weight that is acting over here. And that is what? 30 Newton. See, I'm taking G to be 10. Okay. So whenever you're trying to solve the problem, make sure that G is taken as 10 itself. Okay. So no need to mention again and again. This is 20 Newton. Yes. Now you know that, as I said, if certain problems are given in this way, then you can write acceleration directly as what? What, students? Let's say you know this is the acceleration side. Here what? Let's say if this is MA and this is MB, what? MB is greater than MA. Acceleration is what? MB minus MA into G divided by M1 plus M2. Yes or no? Now acceleration is what? Mg is what? Mb, that is mass 3 minus 1 into 10 divided by m1 plus m2, that is 5. So 3 minus 2, sorry, 3 minus 2. Okay, no problem, Abhay. And you get acceleration to be what? 3 minus 2 is 1. 10 by 5 is 5 ones are 5 twos are. So 2 meter per second square. Yes, very good. Now, talking about the tension that you require. See, tension के लिए तो direct ही हो जाएगा ना. Now you know that for a 3 kg mass, there's a weight acting, that is 30 Newton. There's a tension acting upwards. So you can directly write, this is the acceleration. Here is the acceleration. Okay? So you can write what? 30 minus T is equal to 3 into A. A, you know what is the value. Minus T is equal to 3. A is what? 2. So 6. So T is equal to what? 30 minus 6. And the answer is T is equal to 24 Newton. Very good, students. Okay. Okay. How come T is equal to 0, Abhay? I didn't get you. So this is the answer. Okay. This is how you solve it. Is it good, students? Let me know. Let me know, students. Okay. Yeah, don't worry. I'll be giving the numericals. Okay. Don't worry. In the upcoming classes, we'll be solving JEE and NEET numericals because today will be concept based. So understand the concept, then we'll be solving lot of JEE and NEET numericals. Okay. Okay. Good. Good. So everyone has solved it. So very good on. Okay. Now. Okay. Path, I didn't get you. Okay. Okay. Don't. Okay. So you're telling, this one. Path. So don't why you are hurrying yourself? Like, take your time. It's okay. Don't do mistakes. Okay. Don't do these mistakes. These are very silly mistakes. Okay. Okay. Very good. Now, okay. No problem, Path. It's okay. Okay. Now we'll be talking about something called constraint relations. Okay. Constraint relations. What is this constraint relation? It tells that constraint means that two bodies are not free to move the way they want. Okay. इसका मतलब क्या है? Now let's say I have a body of mass m. देखो यहाँ एक surface है, ठीक है? दो surface है और I have a body of mass m. ठीक है? I have a body of mass m. Now let me ask you a question, students. In which direction this body can move? In x direction or y direction? किस डायरेक्शन में ये मूव कर सकता है? लेट मी नो. एक्स डायरेक्शन. यस, वेरी गुड, वेरी गुड. मतलब ये क्या हो रहा है? हाँ, वेरी. सो क्या हो रहा है इधर? सी हियर, this body is basically constrained to move in only one direction. In one direction. है कि नहीं? है कि नहीं? कि क्या हो रहा है कि दो बॉडीज है, मतलब एक सरफेस है और एक बॉडी है, मास है, एक ऑब्जेक्ट है. लेकिन यहाँ ऐसा, आई मीन द सिस्टम इज सच ए वे दैट इट इज व्हाट, इट इज डिपेंडिंग ऑन अनदर वन. ओवर हियर यू can't move in what y direction, you can only move in x direction. जैसे मान लो अगर आप लोग कहीं बाहर जा रहे हो, ठीक है, एक मेला या कुछ तो है, ठीक है, यू आर गोइंग टू लेट्स से amusing park, okay, amusement park. आपके पेरेंट्स के साथ जा रहे हो, and if let's say you are with parents and if your parents are holding your hand and if you want to move in, like say आपको उधर जाना इधर जाना है, आप जा सकते हो if your parent is holding your hand. अब ये बताओ मुझे, your movement is what, restricted, right? Yes or no? ಹೌದಲ್ವಾ JNV students? Yes or no? You yes. ಇಲ್ಲ. Okay, Path. So that is right. So over here, constraint means basically restriction. Okay. Over here, you are restricted in such a way that you can't move in whatever direction you want to. There is no free will for you. Okay, so that is what it means. Okay, here constraint means two bodies are not free to move in the way they want to move. Okay, over here. So in constraint relation, always remember, students, the acceleration between them are dependent on each other. Got it? See, if there are two bodies, okay, then their acceleration will, let's say, A and B. Okay, then their acceleration will depend on acceleration B. Okay, acceleration A will depend on acceleration B. But how they depend, that we need to check. How they. This is in a general way. I took it in a general way. I just said that acceleration of A will depend on each other. Okay, is it good? Good, students. And here, as I said, we need to find out the relationship between two values of acceleration. So our basic motivation here is to find the acceleration between two bodies. How they depend on two bodies, we need to find it. Is it good, students? Let me know. Let me know. Did you get it? The let's say basic motivation or gist of constraint relations. See, in constraint relation, basically there will be two bodies, and those two bodies are restricted in such a way that their acceleration will depend on each other, and we need to find the acceleration value. Okay, is it good? Nice. Okay, others, let me know path. Kriday and Aishu, very good. Okay, nice. Now, talking about constraint relation, let's say, let me take, see, here are two things you need to consider. Okay, here we'll be talking about movable what? Pulley. Movable pulley will be the basic thing that we'll be talking about. Okay, first initially we'll try to understand what with the fixed pulley, then we'll go to movable pulley. Okay, now you know that, let's say you have a fixed pulley over here. You have a fixed pulley, and you know that there is this mass that is attached, and there will be a mass that will be attached over here. Okay, now you know that if this is mass A and this is mass B, you know that there is a tension acting over here. Let's say this is T, over here this is T, over here this is T, and over here this is T. Now you know that if mass B is greater than mass A, you know that here the acceleration is acting downwards. Hey, ki nahi? आपको पता है, निಮಗೆ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ कि see the mass B will go down and the mass A will come up. Yes or no? Because you know that okay, आपका एक फील आता है ना कि एक फील की वजह से आप बोल रहे हो कि हाँ एक्सेलरेशन नीचे जाएगा, और आपको पता है कि ये एम बी नीचे जाएगा, मास बी विल नीचे जाएगा और ये ऊपर जाएगा, और ये आपको पता है. लेकिन we need to find the relation between what? Relation between the acceleration. We need to find the relation between the acceleration. Is it good? Let me know. Let me know, students. Is it good? Okay. Now, see, these cases are very easy. Okay. Over here, what is happening is, you know that there is this tension. Okay. There is this tension that is need to be found out. And you know that what the other things, that is acceleration, that is needed to be find it out. Yes or no? Over here, there are two unknowns. और आपको पता है कि आपके पास दो इक्वेशन आता है ना, दो इक्वेशन आ जाता है. सो यू कैन सॉल्व दिस इक्वेशन. यस और नो? यू कैन सॉल्व दिस. लेकिन देखो, अगर मैं ये बताऊं कि ये जो पुली है ना, ये पुली भी मूवेबल है, इफ दिस इज ऑल्सो मूवेबल, देन यू नो दैट दिस पुली विल ऑल्सो हैव एन एक्सेलरेशन AP. है कि नहीं? आपको पता है कि एक्सेलरेशन एक बी के लिए भी आ रहा है, एक्सेलरेशन ए के लिए भी आ रहा है, एंड आपको पता है अगर पुली इज मूवेबल, इफ पुली इज मूवेबल देन देयर विल बी एन एक्सेलरेशन ऑफ द पुली. अगर एक्सेलरेशन के लिए पुली भी आ रहा है देन यू नीड टू फाइंड टेंशन. देखो टेंशन वैसे भी फाइंड आउट करना है आपको, एक्सेलरेशन ए भी फाइंड आउट करना है, एक्सेलरेशन ऑफ बी भी फाइंड आउट करना है, फिर आपको फाइंड आउट करना है एक्सेलरेशन ऑफ पुली. अगर ऐसा आ रहा है ना सिनेरियो देन इट बिकम्स कॉम्प्लिकेटेड, है कि नहीं? थोड़ा डिफिकल्ट हो जाएगा ना. ऐसा नो स्टूडेंट्स? या let me know in the chat. Parth, let me know. Abhay, Jamie, Tumkur, Davangere, Bagalkot students, let me know. बताओ. Aishi, let me know. Yes. हाँ. Time. I didn't get you, Abhay. What is time? Yes. See, over here, that is why, for that reason, students, see, over here, what is happening here? Everything is what? Constraint, okay? Everything is depending over here. Yes or no? जो भी mass है, ये mass है, ये mass है, ये pulley है, this acceleration will depend on each other, okay? Depend on each other. For that reason, students, we'll be trying to understand things. We'll be trying to understand things using a method called string method. ठीक है, एक मेथड है स्ट्रिंग मेथड. अगर स्ट्रिंग मेथड से हम क्या करेंगे, बेसिकली फ्रॉम स्ट्रिंग मेथड वी फाइंड relation between acceleration between the acceleration of the bodies, okay? Acceleration of the bodies. Is it good? ऐसे क्यों कर रहे हैं? देखो, जैसे मैंने बोल दिया कि अगर पुली भी मूवेबल है, if pulley is movable then the unknowns is too much, right? There are 4 unknowns, है कि नहीं? 4 unknowns है. अगर 4 unknown सॉल्व करना है, लेकिन हमारे पास जो इक्वेशन आएगा वो 3 इक्वेशन से आएगा. 3 इक्वेशन 4 unknowns आप सॉल्व नहीं कर सकते, है कि नहीं? इसके लिए क्या करते हो ना आप, यू फाइंड द रिलेशन बिटवीन. देखो, अगर आपके पास टेंशन, एक्सेलरेशन ए, एक्सेलरेशन बी और एक्सेलरेशन ऑफ पुली है, अगर आपने रिलेशन बिटवीन ए एंड बी फाइंड आउट किया, या रिलेशनशिप बिटवीन एक्सेलरेशन ए एंड एक्सेलरेशन ऑफ पुली फाइंड आउट किया, या रिलेशनशिप बिटवीन एक्सेलरेशन ए एंड एक्सेलरेशन ऑफ पुली फाइंड आउट किया, देन यू कैन सॉल्व द इक्वेशन, राइट? मतलब 3 इक्वेशन है, फिर 3 अननोन हो जाएगा ना, देन यू कैन सॉल्व द इक्वेशन. यस और नो? देखो, पहले क्या होता था कि फॉर स्टेबल पुली और फिक्स्ड पुली, लेट्स से फिक्स्ड पुली, क्या होता था कि 2 इक्वेशन है, 2 अननोन है, देन यू कैन सॉल्व दिस. लेकिन जहां 4 अननोन्स है और आपके पास 3 इक्वेशन आ रहा था, तो आप सॉल्व नहीं कर सकते. लेकिन अगर इफ यू फाइंड द relations between them, between these 3, then you will be able to solve the equation. Is it good? So that is why what we take the method string method. ये string method क्या होता है? I'll explain it. Did you get the gist of string method now? Let me know, Parth. Let me know quickly. Yes. Okay. Good. Sweetie, let me know. JNV, Bagalkot, Davangere, Tumkur students, Teerth, let me know. Now, okay. Now over here, the pulley is fixed, okay? We'll be talking about string method. ये string method में क्या करना पड़ता है? Okay. Over here, you have 2 masses A and B, ठीक है? Now what you do, from the center of the pulley, draw a perpendicular, okay? Draw a perpendicular. Now let me know, students, can I take this distance from pulley to this mass A? Let me take this as length A. Is it good? यहाँ के लेंथ ले सकता हूं मैं ये? लेट मी नो स्टूडेंट्स, लेट मी नो। हाँ, और ये वाला डिस्टेंस यहाँ से यहाँ तक, कैन आई लेट मी टेक एल बी, ओके। एंड स्टूडेंट्स लेट मी टेक मास ऑफ ए इज ग्रेटर देन मास ऑफ बी, ओके। देन आपको पता है कि एक्सेलरेशन इस साइड होगा, है कि नहीं? ऐसा एक्सेलरेशन होगा, है कि नहीं? एक्सेलरेशन ऑफ ए होगा, एक्सेलरेशन ऑफ बी होगा। ये सब सही है? यहाँ तक सही है? लेट मी नो। Okay, now I want to ask one thing now. Can you tell the total length of the string? Total length of the string मुझे बताओ क्या होगा? L। अगर मान लो, देखो, एक मिनट रुको, आपको देखो, ये वाला एक लेंथ है, फिर ये वाला एक लेंथ भी आएगा ना, ये L नॉट लेता है, ठीक है, और ये वाला एक लेंथ आएगा, देखो ये भी एक लेंथ आ रहा है, सो लेट मी टेक दिस एज L नॉट, और ये वाला लेंथ है, ओके। नाउ टेल मी व्हाट इज द टोटल लेंथ नाउ, अब ये बताओ L क्या होगा अभी? वेरी गुड, दैट इज व्हाट? LA प्लस LB प्लस L नॉट, ओके। नाउ आई एम आस्किंग अनदर क्वेश्चन, विल, देखो आपको पता है कि एक्सेलरेशन हो रहा है इस साइड, है कि नहीं, और इस साइड जब ये मूव कर रहा है masses, let's say up and down, if the masses are moving, then I'll ask you one question again, will the total length L change? अगर मान लो L टोटल लेंथ था 5 सेंटीमीटर, और ये जो टोटल लेंथ था, ठीक है, ये जो टोटल लेंथ था वो था 5 सेंटीमीटर, मुझे ये बताओ अगर ये मासेस मूव कर रहा है अप एंड डाउन, विल द टोटल लेंथ चेंज? लेट मी नो। Okay, good Suman. So what, the length is basically what? Constant. Can I take it? Total length constant ले सकता हूँ? Yes, very good. अब मुझे ये बताओ, एक और है, अगर एक्सीलरेशन इस साइड हो रहा है तो मुझे ये बताओ एल ए का जो लेंथ है वो चेंज होता है कि नहीं चेंज होता है, बताओ। आई एम आस्किंग अनदर क्वेश्चन, विल द लेंथ ऑफ एल ए चेंज? होगा ना? यस, वेरी गुड। क्यों होगा? देखो अगर ये 5 सेंटीमीटर पहले था, फिर मास थोड़े देर के बाद अगर नीचे आ गया, तो इसका जो लेंथ है वो 6 सेंटीमीटर हो जाएगा ना, 6 सेंटीमीटर हो जाएगा। यस, वेरी गुड, वेरी गुड। हाँ, तो इसका मतलब क्या है? इसका मतलब एल ए इज नॉट कांस्टेंट। अगर एल ए कांस्टेंट नहीं है तो एल बी भी कांस्टेंट नहीं है ना? यस, वेरी गुड। हाँ, एल बी ऑल्सो इज नॉट कांस्टेंट, वेरी नाइस। नाउ आई एम गोइंग टू आस्क अनदर क्वेश्चन, इज लेंथ एल नॉट कांस्टेंट? एल नॉट कांस्टेंट होता है कि नहीं होता है, बताओ। विल एल नॉट वैल्यू चेंज? देखो अगर ये एक आर्क था तो एल नॉट का वैल्यू वोंट चेंज, राइट? यस, वेरी गुड। So L naught is also what? L naught is also a constant. Very good. Now we have L is equal to LA plus LB plus L naught. Now what will I do it? I'll differentiate. अगर differentiate करूंगा तो DL by DT is equal to DLA by DT plus DLB by DT प्लस डी एल नॉट बाई डी टी। मुझे ये बताओ, ये जीरो हो जाएगा ना? डिफरेंशिएशन ऑफ कांस्टेंट इज जीरो, एंड ये भी जीरो हो जाएगा। यस और नो स्टूडेंट्स, लेट मी नो। यस और नो? एंड ऑल्सो वी नो दैट change in length with respect to time is what? Velocity. Yes or no? So can I write this as 0 equal to this as VA plus VB plus 0. ऐसे लिख सकता हूं? Let me know, students. Okay, good, very good, very nice. Now I have 0 equal to VA plus VB. है कि नहीं? Now what will I do? I'll differentiate again. ठीक है? I'll differentiate again. अगर मैं differentiate करूंगा तो 0 is equal to dVA by dt plus dVB by dt. ये क्या हो जाएगा? We know that change in velocity with respect to time क्या है? Acceleration है. So can I write it as 0 is equal to acceleration of A plus acceleration of B? Then can I write acceleration of A is equal to minus acceleration of B? है कि नहीं? Now this was the relationship that we got for what? This type of pulley. ऐसा no? देखो, हमें पता था कि acceleration हो रहा है, और हमें ये भी पता था कि acceleration कहाँ हो रहा है. देखो, ये acceleration है, ये acceleration ऐसा हो रहा था ना, क्योंकि mass of A is greater than mass of B. लेकिन हमें ये पता नहीं था कि जो वैल्यू आता था वो क्या हो रहा था. देखो, now you know that acceleration is what? For both masses is same. Yes or no? But in opposite direction. Opposite direction. Yes or no, students? यहाँ opposite कैसे आ रहा है? माइनस साइन की वजह से. अब आपको पता चला ना कि रिलेशन, हमें एक्सेलरेशन का रिलेशन चाहिए तो वो हमें पता चला. Is it good? Let me know, students. Let me know. Okay. What will be I'll be doing is I'll be going back now from here. Okay, from here, just grasp everything what we have studied now. In the meantime, students, if you have any doubt, let me please ask me. And also I'll be launching the NPS. Okay, please answer the NPS, students. So please let me know what should I do much better. Okay, please see, check what we have studied today. Please answer the NPS also. Okay, so what we have done initially, we took for what? Fixed pulley. Over here we have masses, we have the we took the length to be LA, LB and L0. We came to know that the total length won't change, but the total length won't change, but we saw that LA and LB changes and L0 remains constant. Then we differentiated with respect to time, and also we again differentiated with respect to time, and we got the what? The relation between acceleration when the pulley is kept what? Kept what, student? Fixed. Is it good? So please, if you have any doubt, please ask me, students, and please answer the NPS. Please don't leave the session before answering the NPS. Okay, please answer the NPS, students. Okay, good. So see, that's all for today, students. In the next class, we'll be talking the string method for movable pulley. Okay, so in movable pulley, what will happen to acceleration? We'll be finding out the relation of acceleration. Okay, this will basically help you solve very complicated questions in NEET and JW. ये बहुत ज़्यादा important है. Okay, is it good, students? Okay, Parth, in which group are you in, Parth? Okay, drive link. Okay, students. Yes, very good. Thank you for reminding me. Just a second, I'll share the drive link. Give me 1 second. I'll share the drive link here. Give me a second, students. Okay, wait. And thanks a lot for telling me. Okay. Very good students you are. That was very nice of you to tell me. Here is the drive link, students. Okay, just a second. Yes, here is the drive link. Okay, here is the drive link. Please check the drive link once. Please let me know. Okay, students, everyone who has joined in YouTube, thank you for attending. Okay, so in the next class we'll be solving based on that. So before going ahead, here is the homework, students. The homework is for you is to solve for acceleration. Okay, what you need to do is you need to solve for acceleration for what? For fixed pulley. Fixed pulley. You need to solve this. You need to get the relation acceleration of A is equal to acceleration of B. ये आपको बिना देखे करना पड़ेगा. Okay. Okay. Good. So students, and also what we have studied today. Today, first thing we talked about what? Yesterday's class. Recall, yes or no? Then also we saw that the relation for acceleration when there are two masses, that is what? mb minus ma into g is equal to ma plus mb. Yes or no? Where mass of b is greater than mass of a. Yes or no, students? Then we talked about what? Constraint relation. What is constraint relation? In that we got the what? The relation between the acceleration. Acceleration का relation हमें मिल गया. Very good, students. So that's all for students. Thank you for attending today's session. Take care. Bye bye. Okay.